Hi, so in previous video we created a NumPy array that had a sine wave, and we stored that NumPy array after we calculated the sine wave into it as a wave format audio file. And then you can play that file in QuickTime, Windows Media Player, Audacity, or whatever other program you have that you wanted to play a wave file with. However, I've gotten a number of questions about how we would actually play that directly out of the speaker instead of writing a wave file. So we're going to do just that. A quick note, I'll link a couple of other videos below, including the one where I just wrote the wave file, and that will explain to you a bit more the concepts behind what I'm doing with this. Let's go ahead, create a sine wave in a NumPy array, and play it out the speaker. As a reminder, I'm using the anaconda distribution of Python, which gives me most of what I'll need to do this task of playing a sound out of the speaker directly. Look up download anaconda distribution, come to this page, download the version you need, and I'm using the Python 3.6 version. So I'm of course running this on a Mac, as you can see from the screenshot. I have not tested this on Windows or Linux. I assume that it will work very similarly. It's to set up a way to play a sound out the speakers. If you find something else that helps you on those platforms, if you're a Linux or Windows user, please reply in the comments below. So I found a number of ways that I could potentially play sound out of the speakers with Python. A number of them were really old, and I kept looking, and I finally found the Python sound device module. I'll hop over to the command line. Then I did python 3-m pip install sound device like you see here. Just hit enter. Now on your computer, if you haven't installed the sound device module yet, it will show you a progress bar as it downloads. Since I already have it installed, it just says that basically it's already installed on my computer. But either way, you are good to go. So let's start out by importing the libraries we need and the modules. So first thing we need is NumPy. Hope if I spell that correctly. And then we need the sound device that we just installed with pip. And that does have two D's in that, watch out. Then we also need the time module. And we'll use that to program a delay as we play the sound file. Let's see, so now we need to define our samples per second. I'll call SPS, which of course is an integral value, and I'm just using 44,100 samples per second. And then the frequency or pitch, which I'm going to define in hertz, and that's going to be our friend A440. And that can be a floating point value. And I'll make this whole beep 5 seconds long. Now, one trick that I have found turn down the volume of your sound wave when you just calculate it raw, because it can be very loud, very quick, and unexpectedly. So I'm going to define an attenuation. And of course, attenuation is the opposite of amplification. And so having a lower value in attenuation, if it was 1.0 be full volume, 0.0 be totally quiet. So 0.3 is about 1/3 of the way up on the volume after we calculate the waveform. Now my favorite section of the file is what I call the NumPy magic. And this will be what calculates the waveform. So first of all, I'm going to use MPA range to get a list of samples. Okay, and so that makes an integer number for every sample we need in the array, and we'll use that in the next part. with me here. And this recall from our other videos, which I've linked below, is our equation that will then broadcast the sine wave across the NumPy array, then puts it in the waveform NumPy array. Then we're going to make something called waveform quiet, which is obviously the waveform is going to be attenuated. Now here's the code that will actually play the waveform out of the speakers. So unlike with the previous example I did, there will be no intermediate wave file that I write. It'll just open up the speaker and go. And so this is going to actually go ahead and use the sound device module, which is simple enough, but with a catch. We'll get to that in a second. sd.play method requires is, number one, your NumPy array right here, which is waveform quiet, which is what we're going to play. And then it's going to require the samples per second that is stored in that NumPy array. And it can handle the NumPy array as an array of floating point values, which it already is. Let's try playing the script. Well, the file ran, it didn't die, but it didn't play any sound either. So why is that? So if you go to the documentation for the sound device module back here, and you read through it, I won't bother reading through the whole thing now. What you'll find is that your sd.play function will return immediately back to the program. It will not wait to play the duration of the sound. Hence, what you need to do is after it returns, at least in this case, is put a time delay so that the Python interpreter will just sit there and wait for the sound to play before you stop playback and then leave the program. So let's use the time module that we have here to introduce such a delay, and then we'll get a noise. Here's the delay. So I'm just going to use the time.sleep. And I'm going to do that for the duration in seconds. We have the duration in seconds here, duration in seconds here, duration in seconds here. So I'm just going to delay for the duration that I defined in the variables that I put in up here. And then finally, just for good measure, I'm just going to shut down the sound device from playing, switch back over to the command prompt, let's just step back through these steps one at a time just to review what I did. First, I grab NumPy, and that calculates the sound wave. I grab sound device, which then enables me to connect to the speaker and play it directly out of the NumPy array. I import the time module so that we could pause the script long enough for the sound sample to play. Define the samples per second for our sound file at 44,100. Set the frequency of our sine wave to 440.0, which is A4 in scientific pitch notation. Our duration seconds is 5.0 seconds. An attenuation of 0.3 so that the sound just doesn't blast out of our speakers. I then make a NumPy array of integers for each individual sample we'll need to calculate. And then using the equation that I've shown previously, this is the sine wave of those frequency in that number of samples per second across those samples. So that's the tone we want to play. I then attenuated that waveform. After I got to that, then I could play out that attenuated waveform at that particular samples per second rate with sd.play. I then pause the script such that the whole tone can play without it being cut off before it gets done. And then I finally shut off the sound device. And that's it. Pretty simple just to play out a NumPy array outside the speaker. So I hope you enjoyed that. If you did and found it helpful, please like it. Also, if you find other things that have helped on your sound making journey with Python and NumPy, feel free to post it in the comments below. And thank you for watching.